Okay, right, so this is the recap lesson for trig. Okay, we do have a booklet in school that we'll have a little look at too, hopefully when we're back next week. But let's have a look at some of these questions. So the first one is a past E assessment question from 2019. And it's just wanting to find the shortest length. Again, you will have a formula booklet. So in the formula booklet, you should know, looking for all the sides, that you can go and use Pythagoras. So your longest side is C, the other two are A and B. So in this question, if I'm going to look for the short sides, I'm actually going to be subtracting one of the short sides from the big side, the long hypotenuse. So 35 squared minus 28 squared is B squared. Some people like to go ahead and just square root from the start, which is fine, as long as you put it into the calculator perfectly. Let me just double check this answer, because I did just do this question, but 35 squared minus 28 squared, and that means B is 21. Okay, so when it comes to right angle triangles, what are we looking for? Okay, because there's two things that we can use. Sometimes we will use, I don't know why it's not moving. Sometimes we use Pythagoras, sometimes we will use SOHCAHTOA. If you're only dealing with sides, so you have two sides, you're looking for a third, that is when we use Pythagoras. SOHCAHTOA, trigonometry, we use this when we have angles involved. So whether you have one of each, or whether you have two sides and you're looking for an angle, and so on. Even if you have all the sides and you're looking for an angle, you're still going to be using SOHCAHTOA. Okay, so as it's a recap lesson, I am aware that I'm not sure how you would look at this question. In the formula booklet, it will write things like sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. That's where the SOHCAHTOA come from. I do like writing them as triangles instead, just because there's less rearranging. So what I mean by that is SOH, CAH, and the last one TOA. Because that way, if you use it as a triangle, you know whether you're going to either times or divide straight away. Okay? So this first question, it's a nice Pythagoras question. Okay? So you've got the longest side and you're looking for one of the short sides. So we've just done that in the do now. Okay, so I'll just show you the workings. We subtract when you're looking for a short side, and the answer for this one was 12. Because 13 squared minus 5 squared, and then square root will give you 12. Right, it's another Pythagoras question. I want to just go and have a little look at these questions. Okay, so in this one, we have an angle, and we're looking for a side, and it's already been labelled for us, but I'm going to show you how you should be labelling, because it is a revision lesson. So when you have an angle, the side opposite, we call it the opposite. The side opposite the right angle, which is your longest side, we call our hypotenuse, and then the third side, which is in between the angle and the right angle, is the adjacent. So in this question, I'm looking for the side. So because I have the opposite and the hypotenuse, if you look at the ratio, SOHCAHTOA, O and H are together in the first one. Okay, so I like to draw my triangle, S, O, and H. If I replace things with what I know the angle is 35, the hypotenuse is 10, and I'm looking for the opposite. So I'm going to multiply them together. So sine 35 multiplied by 10. Okay, so sine 35 times 10, and the answer to three significant figures is 5.34. And this is meters. Okay, if you're going to have this PowerPoint too, so you can go and have a little look if you prefer doing it the fraction way and then rearranging. Okay, right, the next question then, this time I'm looking for an angle. So this is the angle. So again, this is the opposite, is 7. The hypotenuse we don't know, and the adjacent is 9. You could use Pythagoras and work out the hypotenuse and then use any of the ratios, but I'm just going to use what I have. Okay, so because I have the opposite and the adjacent, I know that I'm going to be using the tangent. So TOA, TOA in SOHCAHTOA. So if I replace them, the angle, I don't know, no idea. The opposite is 7 and the adjacent is 9. So straight away, I know I'm going to divide, but because you're looking for the angle, remember you have to do the inverse function of 7 divided by 9. So if I do 7 over 9 divided by 9, my angle in this question to 3 significant figures is 37.9 degrees. Okay, and if you scroll up, that's how they do it in terms of they put it into the fraction if that's the way you've been taught, and then they do the inverse. Okay, right, let's have a little go at this last question then. So just a couple of triangles put together, and I need to try and work out what x and y is. So if you look for x, at the moment I only have an angle, but I don't have anything else, so I don't have enough information to use SOHCAHTOA. So if you look at the triangle on the left, that has enough information and they have a common side. Okay, so to work out what that side is, I am looking for the opposite and I have the hypotenuse. So if I do my triangle, S, O and H, so if I replace them, I'm going to have sine 38, 13 is the hypotenuse, and I'm looking for the opposite. So I just have to multiply them together. So sine 38 times by 13. Make sure when you put it in the calculator, you close the bracket around the angle. And this question is 8 to 3 significant figures. It's just 8.00. I'm going to change the colour. So now that I know that that is 8.00, I put 8. I can now look at this triangle in the middle for x. So this is the opposite, and this is now the adjacent. So for this question, I'm going to be using TOA because I have adjacent, but I'm looking for the opposite. The angle is tan 62. The opposite I'm looking for, and I have the adjacent, which is 8. So again, I'm just going to multiply them two together. So tan 62 times by 8, and that is going to give me to 3 significant figures 15.0. So it's just 15. Right, in the triangle onto the right, I only have this side. I don't have anything else, but they have a common side, which is in this case, again, the opposite for the triangle to, let's change the colors so we don't get confused. So opposite. So for the triangle in the middle, I can now use Pythagoras to work out the longest side. So 8 squared plus 15 squared, square root that, and that will get me that common side, which I'm looking for. So 8 squared plus 15 squared, and then square root is 17. So this side is 17. So I have the opposite, I have the adjacent, and I need to find what y is. So again, I'm going to use TOA. If I replace, the opposite is 6, the adjacent is 17, and the angle I don't know. So it's 6 divided by 7, but remember you have to do the inverse. So 6 divided by 7, but make sure it's the inverse of tan. And we are, not 7, 17, sorry, that's my mistake. So 6 divided by 17. No, that's wrong. That's completely wrong, guys. Sorry. Please disregard that. Let's do that again. So tan we don't know. The opposite is 17 and the adjacent is 6. My mistake. See? Always double check what you're doing. So this should be 17 over 6 instead. So 17 divided by 6 in the inverse. The answer is 70.6 degrees to 3 significant figures. Go to Google Classroom and look at the task.